All right, so lab 5. So this week, and again, just to reiterate, this is the first time we're using this lab. So there may be a little things. I know we've already talked about some on Teams. I've seen some things come up, and this should really help break some of that confusion, because I think most things are accurate, but there are just like a few little weird things. So anyways, we're going to talk a lot about that. This lab is actually going to kind of take it to the next step, I guess you could say, because for the past little while, we've been doing a lot with select statements and not going much past that. Well, this lab is where we're going to actually start getting into how to create tables and inserting data. So we're not only going to pull data, we're going to manipulate the data and build the structures that hold the data. So I kind of like to, and you've probably already heard me say this, there's the data inside, and you can pull that data out. But then there's the structures that hold the data, like the tables. And in Oracle, they're called objects. Just like any programming language, you have an object. And those objects are things like tables and sequences, and even a column is an object. So we're going to talk a lot about that kind of stuff. But what I really like about this lab is it actually kind of ramps up into it. But the only problem is this lab actually covers quite a bit of stuff. And so this meeting is probably going to take up the full time that I usually allow for meetings, which I say that now and most do anyway, so maybe nothing new there. But we are going to, I'm going to try to seam it all together in a seamless way while keeping to the same structure as the lab. So hopefully it will help all these make a little bit of sense, because the first time I actually read through the instructions, I'm like, whoa, that's kind of weird that they're doing it this way. And then it clicked for me. So I'm going to try to hopefully spare you that step. And in fact, I got my little paper here with my notes on how to go through it all. So we're going to go through it. And we're going to talk about a few different things. And we'll talk about it as we go. So we're going to kind of just jump right in this week. And there's been a couple of questions that have come up consistently, and I'm going to try to address those along the way. So in step 1, now this is step 1 and 2 kind of threw me off because they talk about a subquery. And so I'm like, why are they talking about a subquery, but this step doesn't involve you writing a subquery? So I'm going to talk about that a little bit right off the bat. So step 1 and 2, we're writing just a normal query. However, those queries are going to be used as subqueries. I don't know if they might be, yeah, they're going to be used later on in this lab. So basically you're doing one step here that you're going to use in a later step. So anyways, I'm going to kind of walk you through step 1 and 2. And what we mean by a subquery is a query that goes inside of another one. And so to show you, I actually wanted to really quick write one. And let me close this window. And we may have used one of these before, but we're gonna go over it again just to drill it into our brains a little bit. So let me open up. I'm gonna create a new folder here, or a new file inside lab 5. So I'm gonna create a new text file, and I'm just gonna call it demo5.sql. We're gonna open it. And then we're going to open up our terminal and log in. All right, so a good example of a subquery would be if I wanted the specific telephone number of a person. Now we know that, we've done it before where we got the whole list, and in our database, it's pretty easy that we could just write the join. We could say select T dot, let's get the whole caboodle. So we could see C dot first name, C dot last name, and let's get the T dot telephone number from contact C inner join telephone T on c.contact ID is equal to t.contact ID. Right, so if we were going to run this, a lot of times we'll do something like this, which is great. You know, we can get them all. We could add a where clause and that sort of thing. But let's say we just wanted to do this using a subquery. The other way is we can say select everything from telephone, and I'm going to say select everything just to save some time. And we're going to use a where clause, and we're going to say where contact ID is equal to. Now we're going to select the contact ID from contact where last name is equal to, and we're going to say when and first name is equal to Brian. We'll use Brian. So we can kind of get the data filtered where we only want the telephone number. We could filter it that way and get the telephone record. And so this, you notice right here, we put a subquery, this query inside of another query, and we used it as a parameter per se for this contact ID. Because if we ran this by itself, and this is what's really fun about subqueries, is for the most part, you can paste these in here like this, and it will tell you exactly what it's going to spit out. So in this case, this is identical, or it has the same result as if we just put 1002 here. The only difference is that, you know, it saves a step, or it's dynamic. Because let's say that Brian gets deleted and then gets re-added. Well, all of a sudden his contact ID is not going to be 1002. It's going to be something else. So this would either produce an error or it would pull the wrong person. So we use the subquery. So that's a subquery. And when we bring this all back to step 1 and 2, because it's kind of mentioned twice, it says a query that finds a surrogate key by using the natural key is called a scalar subquery. Now, our example here is more spoken well in step 2. It says you typically use scalar queries as subqueries to discover a primary key and use it as a foreign key value. So in this case, we're using this to, you know, we're using logical data, you know, something we can remember. Because can I remember that Brian Wynn's contact ID is 1002? No, but I can remember Brian Wynn's first and last name. So we use the surrogate key, and and I guess I should explain what a surrogate key is, or in this case, a natural key. So in step 2, it talks about the natural key. The natural key is nothing that's actually defined, but it's something that's natural. And in this case, it's not so good of an example because there could be 2 people with the name Brian Wynn, but it's logical in our scenario to assume that there's only one person named Brian Wynn. And later we're going to use an example where we talk about usernames, and usernames have a unique constraint. You know, just like when you sign up for Facebook or whatever, you know how you can pick like a username. Most of the time they don't let you duplicate those. So those are, they're not the primary key, because the primary key would be system user ID, but the username is unique, but it's also a natural key because it's only natural to assume that there would only be one username. And so in this case, we're going to pretend that last name, first name is unique. And in this case, that becomes a natural key. And I like to think of natural as in it just makes sense, right? So like username, typically you're not going to have 2 people with the same username. It's kind of just natural to assume. So natural, that's kind of how I remember how those work, is those natural things. A surrogate key, you'll also see the word surrogate mentioned. And if any of you guys who know what surrogate means, if you have like a surrogate father or whatever, it's in the place of the real thing. A surrogate is not the primary key, but it's one that can be used similar. So like in the case of system user, username would be a surrogate key. And these are kind of things that are just used to define various columns. So that way, if you're talking to someone, you could say, oh, yeah, no, username is a surrogate key. And that means, oh, it's unique, right? And same thing with natural key. The one big difference is natural keys. A natural key can consist of one or multiple columns. And so like in this case, we have last name and first name. And like I said, like someone like Facebook would not define last name, first name as a natural key if you've ever tried to search for someone. But maybe in our database, it's okay to assume that. I wouldn't, but that's in our example, that's what we're going to use. So, and don't get too hung up on the terms because we're gonna do some more examples. So in step one, what it wants you to do, and it's, as usual, it's way more simple than what it seems to be. But all it wants you to do is write a select statement that pulls the system user ID from system user table where the system user name is equal to DBA1. So if I were to pull up all of my system user, let's just pull them all up here. Say select everything from system user. Let's make this a little cleaner here. So, you know, they want you to find Phineas Taylor Barnum. But let's say that I wanted to pull DBA2 for the sake of being different from the lab. I would say select system user ID. If I could type from system user. And that would pull all of them. So then we want to filter it down. So where system user name is equal to DBA1. Oh, we want to say 2. DBA2. So if we do this, and we get our system user ID. Now, this seems kind of simple. That's kind of what threw me off at first, but this is going to become a subquery later on. And so we'll talk a little bit about that, but just so you know, it's way easier than probably what you want to make it when you first read it. And then, believe it or not, step 2 almost wants the same thing. The only difference is instead of pulling the primary key, we are going to pull the primary key and the surrogate key. And the surrogate key in this case is the username, system username. And we call it a surrogate key because it can uniquely identify a row just like the primary key can. So it's a key that can be used instead of the primary key. So in this case, we still get one result and our database is defined that way. And we're going to talk more about how you actually define those in the future. So for now, we just need to understand what those two terms mean. All right, so there's our 1002 DBA2. So step 1 and 2 should be fairly easy. The only difference is you're going to use DBA1 instead of DBA2, like that. All right, so I guess real quick, any questions about, and I guess maybe hold off on too many questions because like I said, we're going to talk more. In fact, yeah, let's just hold off for a minute because we're going to talk more about this, and I think it'll make more sense if you have questions. But the hard part is here we're going to kind of, I guess, flip gears for just a minute because we talk about subqueries. So you know what a subquery is for the most part. It's a query within a query that returns a single value. That's the important thing about a scalar subquery is it returns a single value. And yeah, we'll talk about it in a minute. Okay, so now we're going to shift gears and we are going to look at some self-joins. So step 3, it wants us to write a query that uses, and I'm going to save you some time here reading this. Basically, we're going to make 2 copies of the same table. So if we look down here at this ERD diagram, we come down here, you'll notice that on every table we have this created by and last updated by. And what this is doing is it's allowing us to see who created and when they created a row in the table, or who last updated it and when they last updated it. Really, it's a security feature because for example, let's play pretend here for a quick minute. Let me describe system user. Okay, so let's say I'm going to create myself a user in my database. So I'm going to say insert into system user, and I'm going to say values. If I can do it here. And then we're going to say system user, I'm going to use the sequence underscore s1 dot next val. And the system username, I'm going to just put my first last, there's my username. The system user group, I'm going to put 2. System user type, and I'm just going to copy those guys. So we're going to say 3, my first name, middle name is Null, last name Crook, and created by, we are going to, and you know what, let's use our subquery. Let's practice a little bit. So we're going to select, and like I said, we're going to use these. So let's say that we want DBA2 to create my my account here. So we're gonna pretend that DBA2, I got hired on, and he was going to create my account. Well, we're only expecting a single value, so we're going to only return the one column. And how I like to format these is like this. There we go. All right, so this is going to pull. In fact, let's just test this again. It's going to pull 1002. So whoever has the system ID of 1002, that's who's going to create me, which in this case is Phileas Fogg. That's quite the name. So that's who created me. And then we have created by, the creation date we're just going to use as right now. And then for the last updated by, we're going to also put him, because update and creation is pretty much the same thing. And there. Put our stuff there. Let's make sure this works. So I'm going to create me. And one row created. So now if I run all of my, if I select everything from system user, you'll now see that I have a record in here. Now, we're going to pretend for a minute that, so they hired me, I'm a new DBA. And let's say that I either don't get trained on proper security measures, or I just am not thinking. And let's say I get some email from a random person that says, hey, you know, I'm a good friend of so-and-so's, and they wanted me to tell you to create me an account on the system. So I say, okay, sure, yeah. And their name is, what's a good hacker name? I can't think of like war games or anything. So let's say that their username, they're like, oh yeah, make my username Morpheus, and my name is John Doe. All right. Well, and since I'm the one creating this, now normally this is like built into software because you have some GUI, but you know, let's say we're practicing good practice. Well, my username was Tanner Crook, all lowercase. So I'm the one who created this. This is why these columns are there. So now we're going to take and say, okay, yep, I'm creating your account right now. Random email stranger. You have an account now. Congratulations. So now that they have an account, they can do whatever they want. Because if we look at this, he's actually now an admin based on his group and user type. So John Doe, or system username Morpheus, is there. So let's say down the road, all of a sudden we find out that someone's been giving themselves discounts on movie rentals. Well, it turns out that it's this Morpheus guy. Well, the boss could come in here and say, okay, I need to know who created this account because he doesn't work here. So basically he wants to know who dropped the ball. And if he's asking you, this is a good chance for you to cover your tracks. Just kidding. That's very dishonest. But, you know, but he wants to track that down. And so in step 3, what we're going to do is we are going to find that data. Now, what's interesting is that system user, the created by, if you look at this, it actually references system user. And so we're going to perform what's called a self join. So if I wanted to find out who created this Morpheus account on our system, I would have to select from system user. So we're going to select, let's select the username, system username, sorry. su1.system username, and we want who created them. And so real quick, I'm just going to say created by, and let's say he also wants to know when it was created. So we're going to pull the creation date. And now we want to know, well, who created him? And you know, let's hang off on that part for right now. So from system user S1. So we're going to run this, and this will pull Morpheus's record. Well, actually, it'll pull everybody's. Let's write our where clause first. Where su1.username is equal to Morpheus. Let's try again. My database that I use all day at work just has username, and so it's really weird to type system underscore user underscore name. There we go. All right, so there we get that. Now your boss is going to look at this and say, "Oh, created by 1003. That doesn't mean anything to me. I want to see his name there." So you say, "Okay," even though you know it's going to be your own. So we're going to write a join. So we're going to say inner join system user, but we're going to give this one alias called su2. And that's the important piece, is we have to be able to tell the computer which ones are which. So when we write a select statement, even before we had this part, just like this, the computer loads system user into memory. So that table is now in memory, and we can do whatever we want with it. Well, when we have 2, it's doing the same thing. Basically, it's making another copy of the table, so we can kind of use 2 at the same time, even though it's of the same thing. So in this case, we want to go from su1.created by, right? Because we want to know who created it. So if we're looking at this record here, we know, oh, 1003 created it. Now, logically, we could just, because we only have a few, we could just come up here and look to see who has system user ID 1003, right? So that's the same steps we want to tell the computer to take. So we know that 1003 in the created by column is going to reference the system user ID. So just, because this was a big problem when I was first learning, this is kind of where I got stuck. It was like, how do I know where to join these? So just if you think logically, like if you were going to do this manually, right, you would look at who the created by, and 1003, and I know that is the system user ID 1003. Well, created by, if it's scroll, created by system user ID. So that's what we're going to do. So su1.created by and su2.system user ID. Because remember, when we pulled the first one, su1 was all of Morpheus's data, right? And so su2 is now going to be all of the data for me, because I'm the one who created him. So, we could even give this an alias of, bad account and perpetrator, whatever. So now what we're going to do is we're going to pull that information. So let's pull and I almost did it again, the system username, and then let's pull the first name and last name. And let's give this a run. And so now we can see all the data there. We can see Morpheus, the ID of me, and creation date, because really this created by is also my system user ID. And to make this a little bit more friendly, we're gonna say as creator first, as creator last. So like if I was going to give the report to my boss, this is what I would put in there. So now we can see the system user name of the bad account, the ID of who it was created by, which really in this case where we have all this other stuff is meaningless. I just wanted it there for, the purpose of showing you. The data was created, and then we can see who the creator was and his first and last name. So then he would be like, well, we're going to give you a training on security or fire you or whatever else. So anyways, that's called a self-join because we took a copy of one table and we joined it to a copy of itself. And that's the big term there. It's a copy, right? It's the same data, just two different copies, but the way we join them can filter data out. So in this case, we only want records where SU1, because SU1, like I said, is all of Morpheus. That's Morpheus's record. And then SU2 is my record, because there's only the two matches. So anyways, that is a self-join. And so when you get to step 3, that's what you're going to be doing. And it should, and this kind of it explains it to you in a way to do it. The only difference is you'll be looking for who created DB1 instead. And we can look at the output at the end, and you'll notice it's very similar. We can see that DBA1 was created by sysadmin. And what's nice is that information is in every table, which is a really good, practice. Because let's say you wanted to know who added that new telephone number, right? Maybe they're doing it wrong. Maybe they just need better training to say like, hey, look, when you put the telephone number in X, Y, or Z, and and I actually, one of the big data systems that I work with doesn't have these who audit columns in every table. And so a lot of times you're like, hey, I want to know who changed this parent's phone number, right? Because they or whatever, so I can talk to them and see what the story was. Not necessarily that they did anything wrong, but I just want to see what the story was. Why, did they change it for the wrong person or whatever? But it doesn't have this data, so I can't look. So anyways, that's really good to have. And again, called a self-join. All right, and step 4 is going to be very similar. The only difference is that it wants to know 2 things. It wants to know who created it and then who updated it, which means that we have to do another join to another copy of system user. So what I'm going to do real quick is I'm going to pretend that I'm changing Morpheus's let's see, what do we want to change? Let's change his first name. So we're going to say, okay, update system user, and we are going to set the first name equal to hackerdo, where system username is equal to Morpheus. So let's say that we're just changing his name. We don't only want to update that. We also want to say last updated by equal to, and let's practice our subquery again. In fact, we can just take it and cheat. We'll just take and copy it from right here. We're going to put our select statement in here, our subquery that will pull my system user ID because that's what we want there. And then we want to set the last update date is equal to sysdate. So let's run this, and we should update one row. One row updated. So now if we pull that previous query that we had, we should see that his name has now changed. I guess that's not in that query. Select everything from system user. And now we can see that his first name is Hacker, and you'll also notice that his, oh, and I set the, let's say that the DBA changed this. Let's do that one more time. Let's say DBA changed this because he wanted to change the name so he recognized it as Hacker. There we go. Let's try again. Because I want our data to be different, essentially. So now we can see his, like again, his name's been updated, but his last updated by is now 1002, and the date obviously is different. So what we're going to do is we want to add who last updated it. So let's first do our join here. So we're going to go after our on clause, and we're going to take another copy of system user, and we're going to call it SU3. And so in this case, now this is again where people get really confused, because even though this is a new lab set of instructions, this is actually a query that's been used in previous labs, because it's a great one to do the self join. So a lot of people will say SU2 dot last updated, or whatever, last updated by, and this will make a big chain reaction where you're not actually seeing who last updated Morpheus. You're seeing who updated the person who created Morpheus, because remember, SU2 is my record. So you'd see who last updated me, which we don't know if that's the same or whatever. So you want to make sure you connect it back to Morpheus, because Morpheus is our home base. That's what we're connecting everything to. That's not always the case. Sometimes you may want to connect to the middle table in a join or somewhere in between. But, we want to make sure we're connecting to what we're looking at. And then when you're doing self joins, it's kind of hard to keep track of, and so you can alias those however you want, but just know that SU1 is Morpheus, SU2 is who created Morpheus, and now SU3 is going to be who updated Morpheus. So then we're going to say SU1 dot last updated by is equal to SU3 dot system user ID. All right, and so now let's pull SU3 dot system username. And we'll just call it updater. Let's run it. And so now we can see Morpheus here. We can see that he was created on the 19th of May. The creator was Tanner Crook. We have the first and last name of the creator. And the updater was DBA2. So the DBA updated it, right? Okay, so those are self-joins. And that's pretty much what you're going to do in step, was it 4? Yep, in step 4. A 3-table self-join. We can come down here and look. Basically, they have the same thing, just a little slimmed down. You have who created it and who last updated by. Does anyone have any question about these self-joins here? Is anyone lost? Does this make sense to everybody? Especially what I really want you to pay attention to is how this is SU1 to SU2 and SU1 to SU3, because that's where we're connecting the data. And really, I think a lot of times, at least for myself when I was learning, I got stuck on worrying so much about like these aliasings. And if you just take a step back and think, okay, SU1, what is that data? Well, SU1 is Morpheus, right? And that's what we're connecting everything to. So Morpheus is created by, right? And we want Morpheus's last updated by.
So in this case, this specific case, does it matter if you do inner join or left join? Is it going to be the same results?
Yes, it would be the same, because SU1, we already have it filtered down to a single row. if that makes sense. And in this case, it actually wouldn't matter because, and I was going to hit on this as well, because this has probably been one of the most brought up questions. I don't know when to use inner join, left join, right join, full join, and that kind of stuff. So really, when you're joining data, you kind of have to think about what the end result is. And really what it comes down to is how much do I want to filter data? Is there matches and that kind of thing? So, for example, in this case, we know that system user table, the created by and last updated by columns are not null constrained columns. So like if we describe system user, we can look here and created by has this not null. And that means that it can't be empty. And furthermore, if we were actually look at the definition of the table, it would say that created by references system user. And so in a nutshell, what that means is that it has to have a match. We can't have a system user record that does not have a created by value that won't work on a join. So an inner join, in this case, it doesn't really matter because there is always going to be a match. But I think we talked about it last week. If we were doing a join from contact to telephone, if I were to actually, in fact, I think did we have one up here? So if I do select everything from contact, you'll notice, or did it delete me? Yes, I am deleted out of here. I put myself in here at one point, I think, and but it looks like I must have ran the cleanup script. But I don't have if one of these people didn't have a telephone number, then we have some dilemmas, because let's say your boss says, hey, we're sending out a text blast and we want everybody who has a telephone number, we need their record so we can give it to the system that sends out that information. In that case, you would say, oh, I want to do an inner join because I don't care about people who don't have a telephone, right? However, if he said, hey, we want everybody's records and we want their telephone number and address, even if they don't have one or not. Usually they don't say that. But if he says, hey, we want everybody's records, that you can assume. And in that case, we would do a left join. Now, in this case, like I said, we kind of get everybody here because everybody has a telephone. But if there was someone, a contact, who did not have a telephone, or if we just didn't know, but we wanted to make sure we had everybody regardless, then we would use the left join. Does that help make sense a little bit?
Yes, thank you.
Okay. And then, go ahead.
Sorry, I had a question about the left and right joins and that kind of thing. This might be a simple question or a basic question. What makes which table the left one and which one makes it the right one?
So it's order of operations. So in this case, and I look at it just like this, and if it helps, put these on the same line. So it's order of operations. So in this case, the left is referring to what's ever on the left of this join statement. So the left would be contact. If I change this to a right, now it means telephone.
Perfect. Thank you.
Yep. And so, yeah, so you can use that to determine, because if I say left join, I'm taking everything on the left, even if it doesn't match. If I say right join, I'm taking everything on the right, even if it doesn't match what's in the left. And let's say, because I'll be honest, I rarely use a right join, just because most of the time logically I'm thinking, and I think it's just because we read from left to right. But, like if I'm saying, oh, all the people and their telephone, from contact C, left join, telephone T. So I rarely use a right join, just because it all, like I said, it's all order of operations. And most of the time I think logically we start with the base table. And I actually have gotten in practice because when I was at Oracle, I spent a lot of time optimizing queries. And to optimize queries, you start with the least and go to the most. So like in the case of contact, you can have multiple telephone numbers per contact. So theoretically, telephone could have millions of records, while contact only has 12. So if you want to optimize your query, you select from contact and then go to telephone. And the reason is because that way it selects little and it filters out before it has to load up all of those rows. So anyways, that's a little bit of a tangent there. Hopefully that helps a little bit. And again, and I'm sure you guys have all been there a lot. I cannot reference it enough. If you Google SQL joins on Google image search or DuckDuckGo image search, whatever your image search may be, it brings up those nice little Venn diagrams. That's a huge lifesaver. I use it all the time. Well, I've got it committed, but I use it frequently. And when I was learning and still trying to learn, I used it all the time. All right, so let's keep plugging away. So we got up to step 5. Step 5 is that plus the created by. So we got there. Because step 4 is just the. Oh wait, no. Let's look. Let me take a look at my notes. Oh, so step 4 is you're gonna find it for where DBA1, right? Just one little where clause. But on step 5, you're going to take the same thing. Step 5 is really a freebie. You're going to take that same query, you're going to copy it, and you're going to take out the where clause, right? So basically to demonstrate the steps you would take is, so this is my step 4 here. I want to take out the where clause. And let's run it. Because basically, instead of seeing it for DBA1, they want to see it for everybody. So now we can see the same information for everybody. So step 5 is a freebie. You just delete your where clause. All right, and then step 6 is where we're going to start getting into some more fun stuff. So like I said, again, we're going to shift gears just a little bit because now we're going to talk about creating tables. And I've said this a lot, and especially before they changed the labs. Because we actually used to start with the create statement, learning how to create tables, and then they changed it. Thank goodness, because it's easier to learn select statements than create tables. But now that you know how to select data, you've seen how data comes out of it. Hopefully it helps a little bit when you create one. So we are going to create a table. And along the way, we're going to talk about a lot of terms that we've kind of already talked about, like primary key, foreign key. And not null constraint. We're going to talk about constraints. So I'm going to kind of walk you through this one just a little bit. And yeah, it should be pretty good. Now this is kind of where these instructions get a little weird because they talk about this tools directory and we don't actually have the tools directory yet. It's coming next term. So what we're going to do is we're going to create this ourselves, this drop rating agency.sql script here. And we're not going to actually write the verify rating, but we're going to put the verify step in the lab. So that way it's just right there. So anyways, let's dive into a create table statement. And it'll talk in, and I'm going to try to tell you how to read these instructions as we're creating it. So shouldn't be too terrible. Let's create a comment here. We're going to create and we are going to create a table called rating agency. And just, I guess, as a little bit of background, the scenario here is that we want to be able to track ratings of movies. So for example, is that movie rated PG-13? And as we all know, the ratings can change from country to country or based on the rating agency. So what we need to do is we need to come up with a way to not only track PG-13, but also the rating agencies, because let's say you're in the UK and you want to rent the movie. Well, our database needs to be able to say, oh, this person's in the UK, use this rating agency, or, whatever. So we're first going to create our rating agency table. And to create it, you start with a simple statement that says create table. Not too hard. And then we say the name of the table. So we're going to create the rating agency table. And then we're going to put parentheses, and this is where we're going to start building out our columns. And so this is where we need to look at our instructions. So they give us the diagram of the table here, and we're going to look at this as we go. So the first column we need is the rating agency ID. Now, it says ID, so we can assume that this is the primary key, which it talks about in there. So rating agency ID. And we want to look at this. And this is where I'm a little, I guess, perturbed with the instructions, because it's going to be a little different. You'll notice that this says int with a size of 10. Well, we're in Oracle, and Oracle doesn't have an integer data type. It has what we call a number. And so what we're going to do is we are going to just type number. So if you see int, don't matter about how many characters it has in it, right? If it says int 10, you just can ignore the 10 and just change int whatever to number. Because in Oracle, a number we don't specify the size. So just put number there. And let's see here. Where does it say here? And I guess real quick as an example, if you need a good example besides mine on how to create a table, we can pull up the create, and let's look at member. We'll just pull up member for an example. So we can see a good example of a statement here on how to create this. So let's keep going. I'm gonna just to show you this, because we're gonna kind of refer back to this since you guys are kind of familiar with this data already. So we have our rating ID and our number, and that's our primary key. And we're going to remember that's our primary key because we're going to define that as our primary key here in a minute. And next we have our rating agency abbreviation. And you'll notice that this says varchar 4, and this is another one where we kind of have to finagle this. And if we pull up this other file, you'll notice it says varchar 2. Well, we're going to use varchar 2 because we're in Oracle. The instructions, this image here was created from MySQL. So that's where the difference comes in, but it's not too bad. So we're going to create rating agency underscore ABBR, short for abbreviation. We're going to put varchar 2, and it wants it to be a size of 4. So on the strings, we want to put the actual size. And what that says is that it can be a 4-character long string. And the reason we restrict strings is because they take up storage space. And if we left that just to the default, which is, I think it's like 200 and something. I want to say 256. If we left that at the full amount, whether or not we use it, it allocated that much room per row. So for Facebook, and we let people have an abbreviation of 256 characters, it take 1 million and times it by 256, bits, bytes, or whatever it is, and that would be how much storage on disk is being used. So you want to give enough room to fill the data you need, but not over the amount. So rating agency abbreviation. Now this doesn't say if we want it to be not null. Actually, it does right here. So it says not null constraints on the rating agency abbreviation, agency name, created by, creation date, last updated by, last update date. So we do need a not null constraint on here. And we've talked a little bit about this. And basically what we're doing is we're saying, look, the abbreviation can't be empty. If you're going to put a rating agency in here, it must have an abbreviation. So we're going to say constraint. And if we look at member has the same thing. right? So you can't have a member without a credit card number per se. So we're going to create a constraint, and now we're going to give it a name. And it's going to be NN rating. Did I put 2 underscores? Yep. Rating agency _1. And if we look at the instructions here, it tells you to name the constraints, name the constraints in that format where n is an integer, so basically just a number. So the first one is going to be 1. And what is our constraint? Well, it's not null. And constraining, if we're constraining something, we're limiting on what you can do. So we're constraining that column, and we're saying, look, abbreviation, you cannot be null. You can't be empty. And we're going to give that constraint a name. So if we tried, it will say that we violated constraint NN rating agency 1, so that way we know what we're talking about. Just so you know, in my databases, instead of putting the table, I actually put the column name so I know which one it is. But either way works. Okay, so next we want to put the rating agency name. So we're going to say rating agency name. And this one is also a varchar 2. And this one lets us have a character limit of 40. And again, we're going to constrain this column because that's what it says in the instructions. So we're going to do a rating agency, and we're going to call this one 2. And it is also not null. And now let's look at what else we have. And so now we're down to our created by, creation date, last updated by, and last updated date. Now, a little pro tip, if you want to save some time, these are all the same. The only thing you'll have to change is the actual name. So if you want to, you can actually take and just copy these. And I'm going to just plug these in here for the sake of not having to type those. And then the only difference is I'm going to format this better. So it looks pretty. And then I'm going to take and change these numbers so that it makes sense. So 3, 4, 5, and 6. All right, so there is our columns. Now we want to define the primary key, and we also need to define our foreign keys because we know created by points to system user. So let's start with our primary key. So let's pull this up here. And in the instructions, it says you should create the table with the following constraints. And we have a primary key constraint on the rating agency ID column. So we're going to look at how to create that. And again, if you need an example, you can pull up the member.sql, and there's a nice little example here for the primary key. But basically what we do is still inside the parentheses, we put a constraint here, and we're going to give it a name. And in this case, we're going to name it PK rating agency. Now we don't have to give this one a number because we only have one primary key. So we're going to have our rating agency, and we're going to tell it that it is a primary key constraint. And then in parentheses, we give the name of our column that we want to be the primary key. So just like here, we have our name, primary key, and member ID. And I guess for the sake of being like that, will be the same. So now one thing you'll notice is in these ones, we put these ones in line with the column name. And notice I said inline. You might come across in the reading an inline constraint and an out of line constraint. These ones are called inline because they're in line with the column definition. These ones are out of line because they're, you know, it's not up there with the rating agency ID. So now let's build our foreign keys. Right now, another little pro tip, if we were going to save some time, we could take and change some of this, but I would recommend learning what this all means first. So we're going to type this one up manually. So we're going to give it a name, FK Rating Agency, and FK is short for foreign key. And we're going to give this one a number because we're going to have multiple foreign keys. And I always forget how to spell foreign. There we go. We're going to create a foreign key on created by. All right. And then it's going to reference. So this one's going to be a little different because we have to put, we have to specify where it points to. So it references system user. And then in parentheses, we put the column that it references. So in this case, system user ID. And I guess we don't need a semicolon yet. And so, like, for example, in member, we can see that the member type references common lookup ID. Same thing with the credit card type. So credit card type, you know, Visa, MasterCard. In the member table, those are like 1001, 1002, 1003, or whatever. That's because it references a common lookup ID. So that's how we define those primary key, foreign key combinations. And a big part of what makes, you know, and I've brought this up before, what makes a spreadsheet different from a database is that we can take multiple tables and build relationships. And that's exactly what we're doing with these foreign keys. We are building a relationship between two tables by doing this. So let's build our other one. So, and now we're going to take this agency 2. We're going to build a foreign key on last updated by, and it references system user ID. All right, and so there is our rating agency table. And it also wants you to create a unique constraint, and the unique constraint is on the, and that's a typo, it wants it on the rating agency name, I would assume. If you don't, where there's an error in the instructions, feel free to leave that off if you want. But basically, we're going to build this table just like this for now, because it really shouldn't make a difference. So now we have our table. So now we can run describe rating agency, and we have our data. And you'll notice that they're all not null with the in this table. So basically, we have to fill them all. All right.
Did you say we did not need to run the drop table first?
That's what we're about to get to.
Okay, sorry, jumping the gun.
No worries. So basically, I'm going to let you guys decide how to do this, but I'm going to show you how to do it as per the instructions, just so we can, because I think part of this is also showing you how you can call other scripts from the script file. So in this case, I'm actually going to take and delete. Actually, yeah, let's delete all but the first select statement and this select statement. So let's pretend that this is my lab here. So we can run that create table, but I just want to demonstrate this real quick. So let's say I do it and oops, I had a boo-boo, or I just want to rerun my file. If I try to run this again, you'll notice I get an error and it says that the name is already used by an existing object. Now, databases wouldn't be very, good, wouldn't be very useful if things only lasted one time. And it's not like we can overwrite things because, like I said, we want to protect our data. Once we define a house, we don't want to override it because it would delete the data inside. So once an object is created, you have to make a choice. Do I want to delete the table and all of its contents or change it? And so in this case, where we're still in the development cycle, we are going to drop it and recreate it. And we can do that using the drop table statement. So I'm going to say drop table rating agency. And you'll notice that it says table dropped. If I try to describe on it, it is gone along with all the data in it. So you don't want to do that on like a production table. But now we can recreate it or whatever, So basically what we're going to do is we are going to, in our script, we're going to write another file that's going to drop this table for us. Now, what I'm going to do is I'm going to go into my Lab 5 folder, and I'm going to create a new folder. And we're going to call this tools, just like it says in the instructions. So we're going to go in, we're going to create that directory, and you can do that. Just right click in there, say create new folder. And then we're going to go into tools here, and we're going to create a new text file. And we're going to call this drop rating agency.sql. All right, and let's open this up. Now this is going to be the script that drops the table. Now this can be as simple, or we can make it complex. So I'm going to show you the simple way first. So I'm going to say drop table, just like we did before, rating agency. All right, pretty simple. And I'm going to save this. And let's just close this for now. So now what I want to do, just like it says in the instructions, it says before you create the table, you should run this script. So I say, okay, so I'm going to put an @ and I'm going to put tools, not a /. We want just tools, drop rating agency.sql. And I'm going to save this. Now I'm actually going to run my actual live script here. So we're going to say @demo5.sql. Let's see. Oh, so I get unable to open file tools. Oh, and I put dropped instead of drop. There we go. Let's try to spell correctly. That helps a lot. Let's try again. And there we go. So now you'll notice that I can run this over and over, and I never get an error, and it will recreate the table every time. So that's the simple way. But now I'm going to show you another way, because let's say that for whatever reason I run the cleanup script or I drop this table myself. So we're going to say drop table, which your cleanup script should run every time. So we're going to simulate that. So if I do this, I'm going to drop the table, and then I'm going to rerun my script here. You'll notice that I get this error. Now this error doesn't mean anything bad happened, because it just said that I couldn't drop it. Well, we were going to drop it anyway, so the fact that it doesn't exist, it's an error, but it's a good error, if that makes sense. But for those of you who like the joy of knowing that you're doing everything right and there's not errors, because I do it myself. I hit in my log file, I hit Control F and I search for errors. So to avoid that, we can use a little script. Now this is outside the scope of the class. That's why I showed you the plain way first. So you can either do it this way and just ignore the error, or if you want, you can do it this way. So if we go into our create folder and just pick a table, any table, I'm going to pick on member. There is this little statement here that says conditionally drop table. And I'm going to just take and copy this. I'm going to close this. And we are going to go back to my, let's open up this tools drop agency here. So instead, what I can do is I can use this conditionally drop statement. And basically what this is going to do is it's going to delete the table for me. Oh, and I forgot one piece. Let's open up member again here. And we want this. Let's pull the comment too so it makes sense. So in SQL, I guess just so you understand what we're doing here, is we can create a variable that we can then use over and over and over again. So basically we create a variable called table name. And in this case, I'm going to change member to what was it, rating agency. So this is where you can change it. So instead of having to change all this stuff down here, I can just change it in one place. And you'll notice this upper, well, that's a function we've used. It changes it all to uppercase. So that's all I have to do. So I'm actually going to take this code and I'm actually going to paste that right in chat here. If it'll work. Yep, there we go. And I will also send that out in fact, did I put it in the instructions, Art? No, I think I told you where it is. I'll send that out also on Teams. But all we have to do is put this in this file, and for any other table we make, we just have to change this one little thing right here. So I'm gonna hit save, and let's rerun my my file here. And you'll notice that now it says PL SQL procedure successfully completed, and that's it, removing the table. Now, if I say drop table rating agency, now before, remember, this threw an error just with the simple drop statement. With this new way, it will never throw an error. And that's because it checks to see if it exists. So you'll say if the object is in, basically if it exists, then delete it. If it doesn't, don't do anything. So it's like a little conditional. So we're going to put that in there. Now with any table, we also want some sequences. And we've talked a lot about sequences. Sequences are what's going to count for us. So this rating agency, and sequences are really easy. So we're just going to create the sequence. And we're going to say create sequence rating agency underscore, and I believe that it just wants S1. And we can, let's say, start with 1001. Start with 1001. And that sequence is just going to count for us. And by saying start with 1001, it's going to start with the ID of 1001. Just like if I select everything from contact, they start with 1001 as well. No reason to do that, just because. So I'm gonna do that, and let's run it. And now you'll notice that it says table created and sequence created. Now, what's nice is if you decide to do it the complicated way, I guess it's not really that complicated, this deletes the sequence for you. If you want to do it the non-standard way, you need to drop the sequence as well by using, we'll do it in the terminal. We could say drop sequence rating agency S1, and that would drop the sequence. So up to you. I wanted to show you both so you could see those drop commands, but this way is a lot easier. And like I said, I'll share this code out, and the nice thing is all you have to do is change this one thing. But the important thing, because we could have just put this in our file, which I guess is the whole point. So in this case, we have this at, which is actually calling the file. So let's put a comment here. We're saying call the file to drop tables. Now, basically what this is doing is it's exactly the same thing as if we just had this in our file. Right? So it doesn't matter. Basically, we're just doing that so you can see how those SQL the stuff works. Now, and even up here, we'll have the calls to this, cleanup and all that kind of stuff too. But basically, you can do that just to make it a little cleaner. So we create the rating agency and the sequence. And sorry, I've kind of been negligent with the chat. So someone asked, are we supposed to create the sequence for the table, for all the tables? And you know what? Actually, I didn't even look at this here. Yes. And so you'll notice that it uses the sequence here. Does it talk about a sequence anywhere in here? I don't think so. I guess that's why I'm here to tell you. So yes, any table we create, you need to create the sequence for. And Oracle is kind of the first one that had this sequence object. So if you've ever used MySQL, it's kind of built into the table. You can say auto increment. But we'll actually talk a little bit in the future, in a future lab, why those sequences being on their own is really nice. Because they are actually nice to have on their own, even though it's something else you have to maintain. Postgres is, I think, the perfect solution because it actually combines. They let you define it with the table, and it creates it automatically for you. So that's my favorite, but it is nice. And I guess just to speak as to why Oracle and not MySQL or Postgres, one nice thing about learning Oracle or similarly Postgres is they are by far, I guess, the more complicated ones as far as they're more feature rich. Let's put it this way, because they're not necessarily more complicated just to be more complicated. They can do more. They're very powerful. The biggest databases in the world are using Oracle, probably. I was trying to think if I could tell you some people that use Oracle, but it would. I think I'm pretty sure it would break my NDA. So, anyways, big places use Oracle. Some of the biggest databases in the world use Oracle. So the nice thing is by learning the more complicated or the more feature-rich one, moving to another database is simple. So I started on Oracle. I obviously worked for Oracle, so that's what we used. And now my main database is I use Postgres and Microsoft SQL Server. And switching, I did the interviews, and it was no problem at all. In fact, you can just be upfront and say, you know what, I haven't used my Microsoft SQL a whole ton, but I know Oracle inside and out, and they're not going to have any problems. So yes, you need to create the sequence, and and it's relatively simple. And if you use this, then you don't need to worry about dropping it. Otherwise, you need to write the drop statement for it. Okay. Let's. Any other questions about creating a table? And we're gonna. We don't have time for another create table example. So, go ahead.
Back on your other page where you've got that / at the end, what does that do?
Okay, so this is called PL SQL, which is SQL. Oh, we don't want to do that. It's SQL, but it's more of like a programming language. So SQL is a scripting language, and PL SQL is the programming language for SQL. It's called the procedural language. So basically what this is doing is this is how the computer knows I'm done with PL SQL, if that makes sense. So it's actually a delimiter. So when the compiler hits this, it says, okay, I know I'm using PL SQL, and when I see this /, that means I'm done, and execute it.
Is that the same for the begin up above? The
Yep.
begin tells it it's in PL SQL, and then okay, that makes sense.
So whenever you see this / in PL SQL, that's actually basically telling the computer that's one miniature program, execute it. So like in this case, it says, okay, create a variable called table name, and it's a varchar. It creates it, and this is what it's equal to, and then execute it. So at this point, this executes as one block, and now we have a variable called table name that's equal to the upper of rating agency. And then later, so that executes, and we're all set. And so then this executes as an entire block because it will hit here, do all of its stuff compiler wise, and then execute.
Awesome, thank you.
Yep. And like I said, this stuff is above the scope of the class, really. In 325, this is all you'll deal with. So I don't want to dive too much into what it's doing. I want to let you know what it's doing so you understand. But do not be confused about this, because we don't need to worry about it. All you need to know is paste it in there and change this to your table name. And it should be that simple. So I'm going to save that.
What about the verify script that it also wants us to do on that step?
Okay, great question, because I almost forgot about that. So it wants you to run this tools verify rating agency. For the sake of simplicity, because we could put this in its own file too, but I think that's slightly uncalled for. So because that doesn't even exist anymore. So what I'm going to say to do is inside of your file, just put your describe rating agency. Save. Let's run. Put that in there so it shows up in your log file, and that's all I need for the verification. Does that work for everybody? And if you want to put it in your own file, you can do that. Yeah, that's what I'd have you put in the other one. We could do all sorts of stuff to query the actual table definition, but we're not going to worry about that right now. Okay, let's continue on because we've got like 12 minutes to get this all finished off. So let's look. So step 7, it wants us to insert some rows. So, and you've seen me write a few insert statements out of necessity, but you know, and here's our row 1 and row 2, and it tells you what we need to put in. And this is where scalar subquery, this is what we wrote in the first couple steps. And you'll see me copy and paste it. You've already seen me copy and paste that same subquery. It's a good one because we use it frequently because every table has created by and last updated by. So now we're going to create our table or our records. So we created our structure, and now we're going to fill that structure with some data. And when I say fill, we're just going to put in 2 rows. So let's insert the rows. And here we are going to say, and this is, I'm going to say row 1. I'm going to say insert into rating agency. Now, for the sake of demonstration, I'm actually going to write out all the columns names. So there's 2 ways you can do an insert statement. I'll show you both. So we're going to insert into rating agency, and we're going to say rating agency ID. Basically list out all the columns. Rating agency abbreviation, rating agency name, rating, oh no, and then just created by, creation date, last updated by, last update date. So like I said, there's 2 ways, and the first way is you list out all the columns you want to insert into. And in this case, all of our columns are not null, so we have to insert into all of them. So this was overkill, and I'll show you the shortcut example if you're inserting into all the rows here in a minute. But now what we do is we put our values, and we just go down the list. So this is a match for match. So if it's the first column name here, whatever value we put here needs to match with that. So for the rating agency ID, we want it to give it an ID. And now this is where we get to use our sequence. So we want to use the rating agency sequence, which is called S1. And this is where we get to say we want you to use the next val, which is the next value in the sequence. And since we say start with 1001, the first value or the next value available is 1001. So we can guarantee that when we do this insert, it will be 1001. And now for our abbreviation, we can look at our instructions and say that it's ESRB. And I believe that's actually for video games, ESRB. And it stands for Entertainment Software Rating Board. Yep, so for video games. And then this is where we get to use our subquery. So if we go back up to where, oh, and looks like I might have deleted it. So we're going to write it again. Anyways, your step 1 should be a good example, but we're going to rewrite it. We're going to select system user ID from system user, where username is equal to DBA1. And I'm going to use, I'm going to use DBA1. They want you to use DBA2, but I'm going to use DBA1, so mine's different. And then on this one, they just want you to put sysdate, and sysdate will pull the current date. So we can do that. And what's nice is we can just take and, since that's the same stuff, we're just going to take and copy that. And then we close off our parentheses. And let's make sure this works. Oh, I got a bad one, and that's because I always do this. I hope that I'm not like making that complicated for you guys, because you see me type username all the time. Okay, let's try that again. And there we go. We get one row created. And we can see that. Select everything from rating agency. And there it is. So like I said, there's in this case, when we insert data, there's kind of two ways to skin the cat depending on what you're doing. And in this case, we have to insert into every column. So instead of writing out each column, if we just want to assume that we're inserting into the same order as the table, which we are, we can do it this way. So we can skip putting out all the columns, and we can just say insert into rating agency values. Now, the only thing is now we have to put it in the order that it shows up in the table. So best practice is to actually list out all the columns regardless. In fact, Postgres, they explicitly say that in the, I guess, documentation, that you should always list out the columns. But I guess just to show you, if you want to skip that, you can skip it if you're inserting into all the rows, and we can just run it like this.
The other nice thing in Postgres is you can leave out what you don't want and just put in the columns you do want.
Yep, and you can do that in Oracle too. But in this case, like I said, we have to insert into all the rows because they're all not null, and so we have to. But you can leave off columns. So like if, for example, when I did my insert into contact, I could have just left off middle name, and because it's a nullable allowed column, I could have just left it off entirely and done that. Okay, but I just created duplicates, so I'm going to run my lab 5 to clean that up. Let's fix it first. So let's fix our duplicates, because this one, instead of being ESRB, it is going to be MPAA, and I don't know what that means, so let's find out. And it is the Motion Picture Association of America. So you learn something new every day, and that's what I learned, is that that's what that means. Alrighty, and there's that. Okay, and it kind of tells you about it, and you can, and then it wants us to select that data, because this is kind of what's fun, is you actually get to select your own verification. So in this case, we're going to write it so it matches, and it wants the select. We want the rating agency ID.
On those lines above, do we want system user or system user name? Oh, never mind. I got it backwards.
Yeah, the only difference is I think in the instructions it wants you to use DBA2.
Okay.
Rating agency abbreviation and the rating agency name. All right, and then for the verification, we can just put that. Let's save and rerun, and we get our verification. And that's what's kind of fun in the future. So after this lab, the verifications will be given to you. But in this lab, because we're still kind of practicing select statements and they're relatively simple, they let you write your own verification statements as practice. Okay, then for step 8, and I'm not going to go through this one because, like I said, we only had time. We're running out of time. You're going to do the same thing, but with a different table. And this one's the rating table. And so this one's actually going to hold ratings. And one other difference in this one is that they want you to separate this one out into its own files in the tools folder. So I'm going to real quick just build that file so you can see me do it. So I'm going to open up my files here. Go into Lab 5. And inside of our tools, I'm going to create a new text file. And this one is called seed rating.sql. And basically what you'll do is you'll write your insert statements in this file. So you'd say insert into rating, blah, blah, blah. And you would go through that. Now, one thing that's going to be kind of, I guess, the challenge per se of this lab is you are going to, because I showed you kind of the simple example where it's just kind of there, you're going to have to build an additional foreign key that references the rating agency. So you'll have the rating agency ID. Let's see, where is that? Or maybe they don't have you build one of those. Yes, you should. You should build one. They don't explicitly state it, but you'll want to build, and I think that's what this is supposed to say instead of a unique constraint. You'll build a foreign constraint on rating, on the rating agent. Oh, no. So you'll do that, but you'll also build, let's see, foreign key. Yeah, so we should build a foreign key. It actually doesn't say it in there, so if you have already done the lab and you haven't done it, no worries. But just like up here, how we build a foreign key to a system user, you'll build a key to from rating to rating agency. Okay, and that'll be, I guess, kind of the challenge because I'm not going to demo that. And then when you get to your inserts, you will write a subquery as the thing. So like if I wanted the rating for MPAA, let's say it's a movie, I would say select rating agency ID from rating agency where rating agency abbreviation is equal to MPAA. And that would be my subquery. So I'm going to let you guys figure that one out, or try to. I'm always willing to help. But, you know, it will be just like created by and how it references system user. The only difference is you're going to change the columns and the table name. All right. So step 9. So this is another new thing. So this is going to be alter statement, and we are going to alter the item table. And basically what we're going to do is we're going to add a column name or a column to the item table. So if I wanted to add a column, it's not too bad. So let's go down here. Or say alter the item table. We're going to say alter table item. And then we are going to add a column. And that, so we're going to say add. And then we're going to, I think it's rating ID. Because right now, if we look at our item table, you'll notice that it doesn't have anything about, well, it has item rating, but it's not tied to anything. In fact, let's say select everything from item and see what that is. The item rating, you know, we have all these in here, but you know, someone could mistype those. So we're going to make our database more sound. So we're going to add rating ID, and it is a number. And now if we describe item, we now have rating ID down here. Now, you'll notice that I didn't put a constraint on that table or on that column, and that's because we can't, because there's already rows in the table. For example, if I say select everything from item now, we get our rating ID, but our rating ID would be null. So if we tried to put a not null constraint on there, it would say, oh, I can't do that because, you know, all these records already have null, will by default have null. So we create that, that column, just plain Jane, don't put anything in there. But then eventually we are going to update it, and we're going to put all of the values in there. And I don't think we ever changed that. Oh, it does want you to put a not null on there. So we'll do that here in a minute. But we can update those values with a subquery. And it tries to talk you a little bit through it, because we do have the item rating column. And it, like I said, it tries to talk you to it. It says the item rating column is non-unique. That should be a natural key of its own table. So basically what you're going to do is you're going to say, okay, we're going to update item for rating ID. So now we want to write our first update statement. So we're going to say update item, and we're going to set the rating ID equal to, and this is where we get to build a subquery. And we are going to select rating ID. Let's tab this over so it lines up. From rating, where, and this is where we need to use a little bit of trickery, I guess you could say. So you'll notice that they up here kind of give you this example, and they give this an alias. So we're going to kind of do the same thing. We're going to say item I, because we need to reference item in here, because we want it where I.item rating, you know, because we already have that, it's NRG, PGG, whatever, is equal to, and let's give rating an alias. I guess let's alias the rest of this. We want it where the rating R dot, and let's look at the table here because I forgot to look. In rating, we have a rating and a description. And if we look at where we insert that data, create the rating table. Let's see. Where do we insert that information here? We just looked it up. Okay, so step 7. Step 8. Okay, I swear I just saw it here. After creating, oh, I guess maybe they want us to give it to you. The seed rating. Okay, well, we are going to write the seed rating table real quick, and I will send that file out to you guys. So let's seed this table really quick. So we are going to open up tools, seed rating. Let's open this up. Insert into rating. And we are going to write a, you know, actually I'll just send this to you. I'll send this to you and it will create all the ratings for us. I apologize for that. I didn't even catch that. And I've been through the lab like 3 times already. Okay. And let's look here. So where were we? Right here. Okay, so eventually, once we actually have data in the table, we want to update it, and that rating column is going to be equal to the rating. So the item rating is equal to the rating. They hold the same data. So eventually, we would write a statement like this, because we're going to say, okay, an item, we want to set the rating ID equal to the rating ID from rating, where the G is equal to G, so to speak. And we might have to add I don't know, that should be the same. So anyway, so it should be not too bad. Let's see if there's any additional information here. Because I don't, yep, so video games don't have a G, so that should work just fine. And like I said, I will get you the data here, so you don't have to write that. And then the last step after you update it is step 10, is you will just write a big query that's going to pull all this information, right? So you get all the member, so you get the account number, the last name. Basically, you're going to pull all the rentals that people have rented and see what the rating is and from which rating agency. And it walks you through the joins pretty good. And just so you know, in this case, you're going to use inner joins through all of it. So inner join, because we only want people that all have matches. So because we only care about people who have rentals. And if they have a rental, then it has an item. And if it has an item, then we want to make sure we have the rating and the rating agency. So at the end, you'll put your stuff here. Okay. So what are we inserting into step 7? What data are we inserting in step 7? So step 7. Step 7, you're inserting the data for the rating agencies. So basically, you're inserting 2 rows, one for movies and one for video games. Now, in this case, we're just doing video games and movies, but let's say we started to expand into Europe, the European video game rating agency is PEGI, I think. So you could use PEGI, and so we could add that. So basically, we're future-proofing our application. All right, and that's the lab. And I apologize, it is a little messy. It's more messy than what I thought. Because I actually read through this like a few times, and I'm like, wow, this actually isn't too bad. It's a little messy. So what I'm going to do is I'm going to put together some refined instructions. In fact, what I might do is I might just annotate over this document, resend it out with some corrections here and there to get that to you guys. And I will also send you a tools directory. Okay, so I will actually send you the whole directory. So you don't necessarily need to worry about creating that file unless you want to beat me to it. But I will give you everything that it says should be in the tools directory, so that way you don't need to worry about it. Yeah, let's see. If you want to hang around after I end the recording, I'm actually going to right now build all that stuff. So if you want to hang around and chat, feel free to do so. If you want to just watch to see how it's done or asking questions. Otherwise, I'm not going to say good luck and leave you at that like I normally do, because I'm going to send out some more information. So look forward to some future communication from me. And I will apologize in advance and thank you for your patience in advance about this lab. Like I said, it's the first time it's being used, and obviously between the image and the instructions, there's a little bit of some hiccups. So anyways, thanks you guys for coming. Hopefully this helps and doesn't add more confusion. I will also put out some more instruction with some highlights and some corrections to the instructions that will hopefully make it quite a bit clearer. And it should be a lot clearer once I send out the tools directory, and it should take care of a lot of that stuff for you. So anyways, thanks for coming. And yeah, look forward to some future communication from me.